Today we're going to learn how to write ionic bond formulas by looking at the two elements or element and polyatomic ion that are going to be bonded together in a binary ionic compound. Let's look at the first one. Directions say look at the first element and fill in the charges of the ion on the table. Well, magnesium, we know magnesium is in group 2. It has 2 valence electrons. It will want to give away 2 electrons, so in the end it will have a positive 2 charge. It will have 2 more protons than electrons because it gave away electrons. Chlorine, in order to fulfill the octet rule, it is in group 17 or 7A. In order to get to 8, it will gain 1 electron, go from 7 to 8, so it will end up having a negative 1 charge. Even though it has 1 less electron, well, that means it has 1 more electron. That means it has 1 more negative charge than it had before, so it's negative 1. So next step is we're going to look at how this affects the number, the ratio, and the bonding. So magnesium has a +2, and chlorine is a -1. Now we know we have to be overall neutral, and so these two balance each other out just like a tug of war, but we still have 1 extra positive charge. So that means we're going to need 1 more negative charge. That means for every 1 magnesium, we're going to need 2 chlorine. That's why we have MgCl2. Let's do another one of these guys. Let's look at aluminum bromide. I'm going to look on my periodic table. Aluminum, it's in group 13 or 3A. That means it has 3 valence electrons. In order to make the octet rule, it will tend to give away electrons. So that means it will end up with a positive 3 charge. It will end up having 3 more protons than electrons in order to satisfy the octet rule. Bromine is a halogen. It is right there, and it's in group 17 or 7A. So in order to satisfy the octet rule, these nonmetals tend to gain electrons. It will gain 1, so bromine would be a negative. So let's see how this would look. We would have aluminum, 3 positive charges, and if we get bromine, well, 1 negative charge, that would be 1 bromine atom. 1 is just not enough. 2 negative charges, 2 bromine atoms. Still not enough to balance it out to make an overall neutral compound. And we have 3. So in order to balance out positive and minuses, we're going to need 1 cation, 1 aluminum, and 1, 2, 3 anions. So now that's what we use to write the formula. 1 cation, which is the aluminum, and 3 of the bromines. Aluminum bromide, AlBr3. And that's how you do that. Let's take a look at one more. We'll look at lithium and oxygen. Lithium oxide. Lithium is an alkali metal. It's in group 1. It's a metal. They tend to give away electrons. To form that octet rule, it will give away that 1 electron and have a noble gas configuration like helium. So we'll go with Li plus, and I will just start out putting that there. Oxygen is in the oxygen family. It has 6 valence electrons, so it wants to be like neon. It will gain 2 electrons to have that octet rule, that stable configuration, so its overall charge will end up being -2. So here is 1 lithium and 1 oxygen. We are not overall neutral, so we're going to need the formula, what it needs to be. 2 lithiums and 1 oxygen. So we need 2 to lithium, 2 of the cations to make our charges equal, and only 1 of the anions. So our formula would be lithium, LiO, and we need 2 of the Li's and only 1 of the O's, so we put the 2 right here, Li2O, lithium oxide. You don't need to put a 1 if that's all you need.